A fair spinner is labelled as shown. The results of the first 10 spinners are P, Q, R, R, Q, S, Q, P, R, S. Okay, now this there's two differences between experimental probability and theoretical probability. We'd all agree that, see the way it's a 1 in 4 chance of each one happening, would you agree with that? Ever agree with 1 in 4? So if I was to spin this 100 times, how many R's should you get? Now that's theoretical, 25 R's, and you should get 25 S's, and you should get 25 P's, and then 25 Q's. That is not guaranteed to happen. You got that? Life's not perfect. So I'll give you an example, okay? If we put this into percentages, this would be or decimals. That'd be 0.25, 0.25, 0.25, and 0.25. Everybody agree with that? Okay, all good. Now, if I alter this by a couple of throws, so instead of sorry, we're just the question sort of secondary at the moment. Just want to, actually, I'm sorry, using the part. I'm using what I'm doing here, guys, is just explain what experimental and theoretical probabilities are. So currently I'm talking about theoretical probability. Why is it theoretical? Because it's what's meant to happen, but it probably won't. Now here's something that I really need to clue you in on here is, imagine we made a small error on one of them. So imagine instead of 25 R's, you got 20 R's. And instead of 25 Q's, you got 30 Q's. Does that make sense? Okay, now look at this. That we're still on 25 S's and 25 P's. Now currently, what's the current percentage of R then? 20 out of 100. Would you agree with that? So that would be a 0.2. That's still 0.25, and this one is still 0.25, and this one's still 0.30. Okay, next time, instead of doing, see the way when it lost 5 tosses and this one went up 5 tosses. You see the way it went up from 25% to 30%, and one of them dropped from 25% down to 20%. Missing 5 scores basically dragged you down 5%. Would you agree with that? Is everybody on board with what I'm saying? Now imagine this was out of 1,000 instead. So instead of being out of 100, it's out of 1,000 throws. And at the beginning, theoretically, what should you get if it's in 1,000 throws? You should get 250 R's, 250 S's, 250 P's, and 250 Q's. Would everybody agree with that? What happens if I try the same thing this time? Does winning or losing 5 extra make much of a difference this time? Let's look at it. What happens in reality if you get 255 R's and you get 255 Q's and the other two stay the same? What does that do to the overall percentage? Not much, does it? You're now on 0.245 R's. You only dropped 0.5%. Would you agree with that? And how much did the Q's go up by? 0.5%. So when you throw it 1,000 times, going up or down by 5 throws doesn't make much difference. But if you throw it 10 or 100 times, going up or down by 5 throws makes a massive difference. Does that make sense? So the more often you throw it, the more accurate your results will be. The more likely your experimental probability will match your theoretical probabilities. You get that? Because small little errors don't make much of a difference. If I threw that 10,000 times and we lost 5, it'd only be a fraction of a percentage. All right, now to get back to the question we're actually doing. All right, that's probably slightly overkill. I'll go over that again one more time another time. So what we have is our question here, and we have PQRS. Write down the experimental probability of the letter Q. It should be a quarter, but how many Q's did we actually get? We got 3, which is 3 out of 10, which is 0.3. Is that higher or lower than what we're expecting? Higher. We were expecting a quarter, which is 0.25. As the number of spins increases, what do you expect to happen to the experimental probability of Q? Do you expect it to be above 30%, or do you expect it to go towards 25%? Huh? Yeah, it should go towards 25%. You got that? It only got one extra, didn't it? Because you either had to be on 2 or you had to be on 3. You couldn't be on 2.5, could you? Because we only threw it 10 times. If we threw that 100 times, we'd expect them to be closer to 25. If we threw it 1,000 times, we'd be expecting them to close in on 250. And let's say you're at 241. 241 is still 21.4%, which is very close to 25. Does that make sense? So we'd expect it to close in on 25% or 0.25. So we're expecting it to go lower. Okay. The probability of Susan's late for school is 0.125. Her school term lasts 56 days. How many days would Susan expect to be late? You multiply the number of days and you multiply it by, that means 12.5%, doesn't it? You're going to miss 12.5% of your school days, so you multiply it by 0.125 and what you get? You're expected to be late for 7 days. Is that okay? Next one. Shh. Tables. Look at this, guys. How many students do we have in total? How many students do we have in total? That just tells us in the question, guys. 25 have blue eyes, 18 have brown eyes, and 7 have green eyes, and the total would be 50 students. Okay, what's the and how many males do we have? 30 in total, and 20 females. Is that okay? First of all, what's the probability the student is male? 30 out of, otherwise known as 3/5. What's the probability the student has green eyes? How many green eyes do we have? Out of how many? 50. A girl is chosen at random. We already know it's a girl, so it's out of 20. What's the probability she has brown eyes? 8 out of 20, which is 2 out of 5. Everybody on board so far? I'll pause it here. Now, next thing. A school has 800 students. How many students would you expect to be? Oh, I'll have a good question for you in a minute as well. School has 800 students. How many students would you expect to be female from that? How many students did we say were female? 20 out of? Which is how many? Which is 40% or 2/5. 2/5 times 800? 320. We'd expect 320 of them to be girls. Does that make sense? Nextly, how many would you expect to have blue eyes? How many blues do we have? 25. No, not female blues. Blues is overall. 15 by plus 10. 25. 25 out of 50. A half. So half the population should have blue eyes. The answer is 400. That is theoretical. In real life, would that happen? Could you scale it up like that? No, but it'd be pretty close. Is that all right? Now, what happens if I said specifically blue and a girl? What would that mean? 10 out of 50, which is 1/5 of your school population. So how many of the girls would be blue eyes? 100 and, sorry, how many of the students would be a girl with blue eyes? 160. Is that all right? Awesome. Now, 15, last one. Really quickly does it. Your chance of getting an A are 15%. Your chances of getting a B are 50%. James, your probability of getting a C? Now, 0.15 plus 0.5 is 0.65, and then 0.65 take away from 1, 0.35. Basically, 15% A's, 5%, sorry, 50% B's and 35% C's. Done. If we spin it 400 times, estimate the number of times the spinner lands on C. Multiply it by 35%. It's 4 times 35, which would be 140. Is that okay with you guys? If I did it in real life, would I get 140? No, but I'd get pretty close, provided it's fair. All right, Dave.